Welcome to the Unit 5 final review video. So we start off with solving equations using substitution. Now this method works well when one or more of the equations has a variable by itself. So we can see that y is equal to x minus 9. So we can take this part, x minus 9, and plug it in for y into the other equation. Now it's important that you put the x minus 9 in parentheses. So from here, we have one variable left, so we can go ahead and solve for x. Using the distributive property, we get 4x minus 36 plus x equals negative 26. I would combine like terms next. 4x plus x is 5x. Then we'll get the x term by itself by adding 36 to both sides of the equation. You get 5x equals 10. So x is equal to 2. Now once we have x, we can easily solve for y by using the bottom equation, y equals x minus 9. Plugging in the 2, we get y equals negative 7. So our solution should be written as an ordered pair, 2, negative 7. For number 2, we have two equations set equal to y. So I could take this negative 2x minus 10 and plug it in for y in the top equation, which gives me negative 2x minus 10 equals 3x plus 20. So I'm going to go ahead and get x's on one side of the equation. I'll do that by adding 2x to both sides. Negative 10 equals 5x plus 20. Subtract 20 from both sides. Negative 30 equals 5x. And then divide both sides by 5. X is equal to negative 6. So now to solve for y, I'm going to go ahead and use the top equation and plug in the negative 3 in for x. Negative 18 plus 20 is positive 2. So my solution, written as an ordered pair, negative 6, 2. Okay, numbers 3 and 4, and actually 5 and 6, we're solving with elimination. Now we first look and see, can we add or subtract to eliminate a variable? So what we're looking for is variable coefficients that are either the same or opposite. Well, looking at number 3, we see that we have a positive y in the top and we have a minus y in the bottom. So if we add these two equations together, the y would be eliminated. So we'll add the two equations together. 5x plus 3x is 8x. The y variables cancel out. 41 plus 31 is 72. So we'll divide both sides by 8. And we get x equals 9. Now, solving for y, we're going to use one of the two equations. Now, in substitution, it was solved for the variable we're looking for. This is going to require a little more algebra. I'm going to use the top equation. So I'll plug 9 in for x. And I'll go ahead and solve for y. And I get y is equal to negative 4. So my ordered pair would be 9, negative 4. For number 4, we see that the x coefficients are the same. So what we're going to need to do is subtract the two equations. So 5x minus 5x is 0, eliminated. 4y minus 3y is y, and 14 minus 8 is 6. I'll pick that equation. I'll plug in 6 for y, and then I'll solve for x. So 5x plus 18 equals 8. Subtract 18 from both sides. 5x equals negative 10. And divide both sides by 5. X 2. So my ordered pair would be negative 2, 6. Now in problems 5 and 6, we can't just simply add or subtract to eliminate a variable. That means we're going to need to multiply one equation, or possibly both equations, by some constants in order to be able to eliminate. So when I look at number 5, I notice that 2 and 4 are the coefficients for x. And I know that 2 goes into 4 2 times. So if I multiplied by a positive 2, they'd have the same coefficient. But since I like opposite coefficients, so I can simply add, I'm going to go ahead and multiply the bottom equation by negative 2. So I'm going to rewrite the top equation, and then I'm going to write the bottom equation after I've multiplied by negative 2. And I get negative 4x minus 8y equals negative 64. Now I can add these two equations. X variable, eliminated. Negative 5y plus negative 8y is negative 13y. And negative 1 minus 64 is negative 65. Dividing both sides by negative 13, we get the solution's y-coordinate, which is 5. I'm just choosing the bottom equation to solve for x. Plug in 5 for y. Subtract 20 from both sides. And divide both sides by 2. And I get 6. So the solution is going to be 6, 5. Okay, number 6, once again, we're going to need to multiply. Look, 2 doesn't go into 3 evenly, and 2 doesn't go into 9 evenly, so I'm going to multiply both equations. So I'm going to focus on the x, just because these are smaller than 9. And the least common multiple is 6. So what I'm going to do is I'm going to multiply the top one by 3, and the bottom equation by negative 2. Notice that the number parts are just flopped, and this will always work. I wanted this to be negative so that I'd have opposite signs. So I'm going to instead write this over here to the right. So I get 6x plus 27y equals negative 12. And for the bottom equation, I get negative 6x plus 4y equals negative 50. So adding these two equations together, I get 31y equals negative 62. Dividing both sides by 31, y. So I pick an equation. I'm going to pick the bottom one. And I'm going to plug negative 2 in for y. Remember, this simplifies to positive 4. We get 3x equals 21. X is 7. So our solution would be 7, negative 2. Okay, so for 7 and 8, I wanted you to use the calculator's matrix functions to find the system of equations solution. Now, before we do that, we need to make sure that both equations are written in this exact form. Some number times x plus some number times b equals the constant. In this case, it is. So when I write the augmented matrix, all I'm going to do is write these coefficients. 9, 13, 27.5. 5, negative 9, negative 114.5. And that little dashed line just means it's an augmented matrix. So then I'm going to put that matrix into the calculator. So to get to the matrix, you're going to push second, and then the x to the negative 1 button, which has the word matrix above it. Let's try that again. Then, first I need to edit the matrix. Now notice that these matrices have 2 rows and 3 columns. So I don't need to adjust the dimensions, but this is where I would adjust it if I needed to. So here I'm going to type in the 9, the 13, and 27.5. And down below 5, negative 9, and negative 114.5. So now I've got the matrix into my calculator. I'm going to go ahead and go back to the home screen by pushing second and then mode. And now I want to do a math function on the matrix. So I go back to the matrix menu, just like I did before, and I'm going to go over to math. I'm looking for RREF, reduced row echelon form, which is selection B. So I push it, and it's going to just paste that to the home screen, and this is where I need to put matrix A into the calculator. So I go back to the matrix menu. I just push enter because that's already selected for A. And when I push enter, it's going to give me the solution matrix. So what the top one is saying is that 1x plus 0y equals negative 8.5. And the bottom is saying 0x plus 1y equals 8. So we can see that the solutions are at negative 8.5, 8. And that'd be our solution. For number 8, notice that we don't have the x's, y's on the left side and the constant on the right side. So we need to use a little algebraic manipulation to do that. So for number 8, we can see that if I added 4y to both sides, I get 5x plus 4y equals 17. Then for the other one, I'm going to have to add x and a 4y to both sides. And that's going to give me 3x plus 4y equals negative 3. I'm sorry. I wrote this problem down wrong. This should be a positive x. My apologies. So instead of adding x, you're going to subtract x. So it's going to change that to x plus 4y equals negative 3. So for our matrix that we're going to put in the calculator, we're going to put 5, 4, and 17 on the top, and on the bottom 1, 4, and negative 3. So go back to the matrix menu. I want to edit matrix A. I'm going to put 5, on the top row 5, 4, 17, and on the bottom 1, 4, and negative 3. So back to matrix, math. Remember, I want to choose RREF of matrix A. And we see our solution is 5, negative 2. Okay, for the story problem, you had to set up the equation, but then you could use your choice of methods to solve. So I have 5 hot dogs, 3 hamburgers, have a cost of $16.47. So I'm going to say X is the hot dog cost, and Y is the hamburger cost. So the first sentence could be rewritten as an equation. 5x plus 3y equals 1647. And then the next equation, 6 hot dogs, so 6x, plus 2 hamburgers equals $15.70. Now, you could use elimination. You could use substitution. I wouldn't recommend substitution. I'm just going to go ahead and show it the matrix. So I go to the matrix, I edit 5, 3, $16.47. On the bottom 6, 2, and $15.70. So see that a hot dog has a cost of $1.77 and a hamburger $2.54. Okay, then graphing systems of inequalities. That'll be our last part of this unit review. These are both in slope-intercept form, so these are pretty easy to graph. So for the top equation, or I should say inequality, I see that the y-intercept is at 0, 3. So I go to 3 on the y-axis and I put a point. Then the slope is 2/5, or 2 over 5. So from the y-intercept, I'm going to go up 2 and to the right 5. I can do that again if I want to put points to the left. Now I have to decide which type of line I'm going to use for my boundary line. Now, because it just says less than and not less than or equal to, I'm going to use a dashed line for my boundary. And less than means I'm going to shade below the line. Now, normally I'd shade pretty dark if it was just one inequality, but since we have two, I'm just going to shade it very lightly. You'll see why I do this in a moment. Now I'm going to go ahead and graph the other inequality. I see the y-intercept is at 7. 0, 7. Then the slope is negative 2, so we're going to go down 2, right 1. I'm going to do that several times just to give myself a good guide. But this time I'm going to use a solid line because it can be equal to the boundary. And here it's also lessened, so I'm going to shade below the line. Once again, I'm shading lightly. Now, I use different patterns for the two inequalities, which makes it easy to see where they overlap. Then where they overlap, we're going to want to make that noticeably darker than the other two regions. So this part right here would be the solution to that system of inequalities. Okay, for number 2, we have a vertical boundary line of x equals 4. So we're going to go ahead and draw a vertical line at x equals 4. You can put a point there, put a couple other points up and below it just to give yourself a guide. And since it cannot be equal to, we're going to go ahead and do a solid line with the points. Now, since it's not y, we can't shade above or below this line. We can only shade to the left or right. Well, x is greater than 4. Well, just think of a number. What's bigger than 4? Well, 5, 6, 7, 8. So every number to the right is bigger than 4. So our shading is going to be done to the right. Now, this inequality is not solved for y. So I'm going to do that below here. So I'm going to subtract 2x from both sides. We get negative 3y is less than or equal to 9 minus 2x. And then we're going to divide both sides by negative 3. Now, when we divide or multiply by a negative number with inequalities, we must flip the inequality sign. So this less than or equal to becomes greater than or equal to. So y is greater than or equal to 9 divided by negative 3 is negative 3. And then negative divided by negative is a positive, so we get plus 2/3 x. So this is the inequality we're going to graph. We can start at negative 3, put our point. We're going to go up 2, right 3, put a point. Up 2, right 3, put a point. And then we're going to graph with a solid line because it can be equal to. It's greater than, so I'm going to shade above the line. We see the overlap is this top right corner. And so that would be our solution. I want to thank you for watching. Good luck on the final.